or they were the same line. Those were the three options we got. However, if both of our systems weren't linear, they could meet more often than that. Think about if you have a parabola and a line. How many times could those meet? If you have a parabola and a line, what are my options? They could meet twice, they could meet once, or they could meet not at all. Okay, so if we have nonlinear functions, we have to think about it. We don't just have one, no, or infinite solutions. You know, in a parabola and a line, those would be the graphs that would show us the three cases where they met not at all, once, or twice. If I had a circle and a parabola, you know, we would have to think about how many times they could meet. So we do have to be a little bit careful. If it's not linear, we might get multiple solutions in those cases. We are just going to solve nonlinear systems today. So nonlinear means we might have x and y to a power. X and y could be multiplied together. We're going to have to look at those things. But we will use the same strategies as yesterday. So substitution and elimination are the options that we have. So if I were to look at this one. Okay. Yes, that would cancel the x squared, but there might be an easier option. We essentially have like three variables here. We have an x squared, an x, and a y, right? Can we solve an equation if it has both an x and a y in it? No. Can we solve an equation if it has both an x squared and an x in it? Yeah. So let's try to cancel the y's. How could I do that? Just add them. They're already opposites. So if I just added these together, x squared plus x, those are not like terms, so it just remains x squared plus x. Negative y plus y, those drop out. 4 minus 2 would give me a 2. Now what would we have to do to solve this? Right. It needs to be a quadratic, so set it equal to 0. And then box method. We could just do the shortcut here. Multiply negative 2, add positive 1. Plus 2 minus 1. So I get x equals negative 2 and 1. Alright. So from here, I have two different x's. We have to find the y that goes with each of them. If x is negative 2, which equation do you want to plug it into? The bottom one. So negative 2 plus y equals negative 2. If I add my 2 over, I get y equals 0. So it would be the point negative 2, 0. If x equals 1, plug that in, 1 plus y equals negative 2, so y is negative 3. So it would be the point 1, negative 3. So in this one we got two possible options. If you recognize from the original, this was just a line, what would this one be? A parabola. We had a parabola and a line, so they met twice. How could you check your answers?
Well, you can't have negative 2.
You can because you can square it, so it's okay. To check our answers, we just have to plug them back in. And you would check both solutions and both equations if you wanted to do that, and they should all work out. Okay. Questions on that one? Why don't you guys take a second and see if you can work this one out. Okay, most of you just started right away adding these two equations because y squared and negative y squared cancel. So you get 3x squared equals 12. Divide by 3. Then to get rid of a square, we would square root with that, plus and minus. So we get positive and negative 2 for our answers. We have to plug those in and find our y. So if x is 2, if I were going to put that in the first equation, I get 4. If I subtract that over, I get y squared equals 0, so y is 0. So 2, 0 is a point. If I plug in negative 2, negative 2 squared plus y squared equals 4. Negative 2 squared is 4. Subtract that over, you get y squared equals 0, so you again get 0. So 2, 0, and negative 2, 0 are my answers. You can check them real quick. 2 squared plus 0 squared is 4. 2 times 2 squared would be 8, minus 0 is 8. And check the other one. Alright. Are you ready for more of a challenge?
Not really.
You guys aren't very adventurous.
Nope, not now.
Alright. This one is not as clear cut. If I just add these, nothing cancels out. Do we have any ideas what we might try? Okay. Which one? Does it matter? No. Okay, so if I take this times negative 1, then I have x squared plus 3xy plus y squared equals 22, and negative x squared plus xy minus y squared equals negative 6. Now, if you add those, x squared and negative x squared would cancel. 3xy plus xy is 4xy. Y squared and negative y squared cancel. Equals 16. Okay, well I got rid of a lot right there. I got rid of an x squared and a y squared. I still have an xy. So am I going to get x equals a number right here? No. But what we could do is get an expression that we could then use substitution to evaluate. So remember yesterday some of the problems we used substitution, we would get x equals y minus 3. And then we plug that into the other equation. So let's say, it doesn't matter which one I solve for. If I solve for y, I would divide by my 4x. So y is 4 over x. So we started out with elimination, and we eliminated 2 things. Wasn't enough, so now we're going to have to substitute. So I'm going to come up one of the original equations, and I'm going to plug this in. Do you guys care which one? Okay, let's go with the second one then. So x squared minus x times y, which is 4 over x, plus y, 4 over x, squared, equals 6. So we have x squared. X times 4 over x would just be 4. This would be 16 over x squared equals 6. Alright. Not real pretty. What can we do? Okay, you could add your 4 over to get your constants together. Can we solve this with the fraction in it, or do you wanna get rid of it? How would I get rid of the x squared on the denominator? Multiply by x squared. So if I take everything times x squared right here, I get x to the fourth plus 16 equals 10x squared. I don't mind to bring over my 10x squared. Exactly. This is like a quadratic. X to the fourth would break into x squared. Multiply to 16, add to negative 10. Negative 8, negative 2. Okay. So x squared is equal to 8 or 2. Am I done? You can square root. With a square root, you add plus or minus. Square root of 8 can be broken into a 4 and 2, so you get 2 radical 2. And plus or minus radical 2. So how many different answers for x did we get this time? 4 answers for x. So I need the y value that corresponds to each of these. Okay, so far this problem has been a lot more involved than the previous one.
Wouldn't that be 3? Because y equals 4 over x, and then plus minus 2 radical 2 x.
Yes.
That'd be 3.
So, well, we'll have to put in the positive and negative, so we can simplify, we might get some of the same things back out. So we have our 4 answers for x. Are there any questions on what we've done so far to get here? It was a little bit longer, but it's really just that algebra. You know, we started out with elimination and then we went to substitution. You have these answers for x. You could plug them back into the original, or, like Connor just pointed out, we have a really easy place to plug them in. I already know that y is just 4 over x. So do you want to plug them in the original, or do you just want to plug them in right there? That would be a lot faster. Okay, so if x is 2 radical 2, and I plug that in, y would be 4 over 2 radical 2. Can you leave a radical on the bottom? So we get 4 radical 2 over 4, which is just radical 2. So 2 radical 2, comma, radical 2 is an answer. Now, what would happen if I put in a negative 2 radical 2? Do I need to work it out, or do you guys know what the answer is going to be? Should just give us a negative radical 2, shouldn't it? If all I did was go back and change these two negatives, all it's going to do is make my final answer negative. So the second point would be negative 2 radical 2, negative radical 2. Okay, if I put in radical 2, multiply your radical 2 on top and bottom, you get 4 radical 2 over 2, which is 2 radical 2. So when x is radical 2, y is 2 radical 2. So my final point, when x is negative radical 2, what's my y going to be? Negative 2 radical 2. All we do is switch that one to a negative. Okay, so that one we got 4 different answers. Definitely a more involved problem. Are there questions on that one?
If there's no other test like that. Because I ain't gonna do it.
Oh,
Might just get it.
see, that kind of actually makes me want to.
You go ahead. It's like you actually got to try and audit.
How do you get 4? It's like, you have, you have 4 2 radical 2, and then all of a sudden you have 4 over 4.
When you multiply the bottom, you get 4 radical 2 over 2 radical 4. When you multiply
Okay. Yeah.
those
Okay.
together. And that gave you 2 times
Okay.
2, which is 4. Other questions? We're gonna try a couple more before we quit. Look at this one. X squared plus y squared equals 16. That's actually a circle. Second one is an absolute value graph. So I need to know where these two things are going to intersect. We can't just multiply by a negative and add these together, because nothing's going to drop out. I have an x squared, a y squared, an absolute value, and a y. So nothing's going to go away. Let's try substitution. I don't really want to use the first equation because I don't want to add square roots into my problem, so I'm going to take the second equation. Let's just solve for that absolute value. So the absolute value of x is equal to 4 minus y. Now, I'm just writing this down to explain my thought process. I'm going to have to plug that in up here. If you take an absolute value and square it, is that the same thing as if you just took a regular x and squared it? Absolute value just means it's a positive number, and you square it, so you get a positive, right? If it's a negative and you square it, you get a positive. So aren't those the same thing? So because this is squared, I'm just going to be able to substitute my 4 minus y in for my x up there. To square this, what do we need to do? Wait. So we get 16 minus 8y plus y squared equals 16. Oh, I dropped a term, didn't I? There's a second y squared there. This is what I got from my foiling, plus the y squared that was already there. If I add my like terms, y squared plus y squared is 2y squared minus 8y plus 16 equals 16. What happens if you subtract your 16 over? What could I pull out of this?
2y.
Okay, and that would leave me with 1 minus 4. So now we know y is equal to 0 or 4. Okay. We have to plug this in somewhere. You can go with one of your two original, you can go with this one if you're comfortable with dealing with solving the absolute value equations. It isn't going to make a bit of difference. So if I did use that, if y equals 0, that means the absolute value of x is 4 minus 0, so the absolute value of x is 4. What numbers have an absolute value of 4? 4 and negative 4. So I got two answers. 4, 0, negative 4, 0. If my y value is 4, then absolute value of x is 4 minus 4, so the absolute value of x is 0. So what has an absolute value of 0? 0. So my final answer was 0. We got 3 solutions on this one. 4, 0, negative 4, 0, and 0, 4. I'm going to give you guys one more to try. any questions on that one? Here's your problem.
It is
Good. So we have negative 3x squared minus 3y squared equals negative 15. And we didn't change the second one. When you add them, the y squareds drops, so negative 3 plus 4 would just be a 1x squared equals negative 4. You add your square root plus and minus. Square root of negative 4 is 2i. So x is plus and minus 2i. Okay, so to find our y, if you plug in a 2i, two I squared would become 4i squared, which is negative 4. So y squared is 9, which means y is plus or minus 3. So that means x could be 2i and y could be 3. Or x could be 2i and y could be negative 3. If you plugged in a negative 2i, is anything going to change here? No, because you're going to start out squaring it, and it's going to turn into the same thing. So if x is negative 2i, you're going to get 3. Or you could have x be a negative 2i and get negative 3. This one had 4 possible answers. Any questions for me? The assignment is a handout posted on Classroom. It's, I think, 6 questions, so not a real long